What if black holes are not cosmic monsters at all, but the engineers that carved the universe's skeleton, holding its outer parts up and even setting its rhythm? In the energy filament theory, black holes are not the end of physics where everything just falls in. They are the most extreme places where the underlying energy sea is reshaped. And that reshaping organizes matters on every scale. If every force is really just the energy sea bending, tightening or twisting, then black holes are its heaviest tools. They do three huge jobs. First, they carve the large-scale skeleton. Textbooks say a black hole makes a deep gravity well and pulls things in. Here that is only the start. Imagine the energy sea as a huge rubber sheet. Pressing once makes a dent, but pulling hard in one direction, day after day, cuts a crease into the sheet. A spinning black hole does that to the sea around it. Its rotation drags and stretches the sea along its spinning axis, aligning the local tension lines until they become long, straight grooves. Along those grooves it is easier for matter and light to move, so galaxies and gases naturally prefer to grow and flow there. Now multiplied by many black holes across cosmic time and you get a network of grooves that join and cross, which shows up to us as the filaments and nodes of the cosmic web. The web's backbone is not piled up by dark matter first and then noticed by black holes. It is largely scratched into the sea by black holes, and matter later fills in those scratches. Second, they help hold up the outer parts of galaxies through the way they stir unstable particles. Space is full of short-lived particles that flicker into existence and decay. While alive, they tighten the sea a tiny bit, and when they die, they kick a small disturbance back into it. Near a black hole, the sea is violently disturbed, so these unstable particles are created and destroyed far more often. All those brief tightenings and relaxations averaged over time into an extra, invisible tension floors around the galaxy, like a very shallow but extended dent in the sheet. From far away, that extra floor looks exactly like a halo of transparent mass that helps keep the galaxy's outer disk bound. So we call it dark matter. In this view, it is not a separate substance. It is the combined effect of black hole agitation plus swarms of unstable particles building a persistent gravitational base. Third, black holes write the rhythms that galaxies follow. Deep inside, matter and the energy sea are churning like the core of a boiling pot. That churning sends out waves of tension, and the layers above act like pistons and membranes that sort those waves into roughly repeatable beats. Some of that pattern leaks outward and imprints itself on the surrounding sea as slow, large-scale pulses. Those pulses do not vanish at once. They spread outward and gently steer how gas piles up, where star formation is dense or sparse, and how spiral arms unwind, whether tight and interleaning or loose and flung outward. A calm, steady central black hole tends to give its galaxy a more regular, symmetric structure. A more chaotic, violently feeding black hole tends to seed asymmetry and bursts. The galaxy, in a very literal physical sense, is dancing to the breathing pattern of its central engine. Put these three roles together and the label changes completely. A black hole is not just a bottomless pit. It is a structural engineer that etches the bones of the cosmic web, a support engineer that helps hold up the outer disk through average tension, and a timing engineer that writes beats into the sea for whole galaxies to follow. It pulls out lines, shapes slopes, seeds tension floors and stamps rhythms, turning raw energy into organized structures. Seen this way, black holes are not the universe's dead ends. They are some of its most important starting points for ordering. Tap follow, share it on New Physics, Clear Universe.